So this is a very interesting SPM question, which is somehow an application for the solution of triangle and a bit of knowledge regarding quadratic function. So we need to know, we need to find the maximum area of the rectangle which is inscribed in the triangle with length of sides 10, 17, and 21. So what is meant by inscribed is like it's such that the rectangle is drawn, and imagine that rectangle, it expands inside the triangle, within the triangle, until to the point that it touches, no matter the edge or the vertex, it touches one of the sides of the triangle. So for the edge, for one of the sides of rectangle, it must lie exactly at one of the sides of triangle, maybe at 10 or 17 or at 21. For example, I can draw the green rectangle like so. So it could look something like this, and I want to draw something exact. For example, I want to draw something like this. This is the horizontal, the vertical sides for rectangle, and this is the area I need to find. So this is the A, or I can say S in this case. So on which side? Well, on 10 or on 17 or on 21, which side will give you the largest area of the rectangle? Well, obviously it's 21, because when you imagine you expand from this side, this 21, you will get the largest expansion of the length of the rectangle. So if you expand along this length of 21, the length of the rectangle would be the largest. But at the same time, well, it's the height or the breadth of the rectangle will be also larger compared to those with 10 and on the side of 17. And so we try to assume that this rectangle, this green rectangle, provides the largest area of the rectangle. Well, it's not really enough. There's not really enough information here. So we try to make some, well, how about we think we can do something like a coordinate geometry. We can try to do a coordinate geometry method. So instead of having just a triangle, why don't we just try to do a graph of x and y axis like so. We have here y axis and we have here x axis, which exactly lies on the 21 here. So this is x. And we need to find the coordinates of each point that I have shown. So we need to find this, the very top vertex of the triangle. So how can we find? We can actually use some application of Pythagoras theorem by considering the fact that this height of the triangle is just equals to, in this case we have here x, and then in this case we have here, well, 21 minus x. And so in terms of x, we can actually express the h here, the height of, or the altitude of this triangle in terms of x. For example, we can use this part of the triangle and we can obtain 10 squared minus x squared as the h. Or h also equals to 17 squared minus 21 minus x squared. And we equate both of the equations here, which gives you 100 minus x squared equals to 289 minus 21 minus x, and then close bracket square, which gives you at the end x equals to 6. Well, which means x equals to 6 and 21 minus x equals to, well, 15. These are very important things we're gonna use for stating the coordinate points. And so we can actually deduce the height of, or the altitude of the triangle. My apologies, I should have mentioned this is h squared. It's not h, because h, according to Pythagoras theorem, it should be the square root of the differences of squares. So we have h in conclusion. For example, we can take this, the square root of 10 squared minus 6 squared, which is equivalent to 8. Or you can actually use this one, which gives you the same answer, which is 8. So back to the coordinate geometry perspective, we can actually observe the fact that this point, which exactly lies on the y-axis, gives you the point 0, 8, where 0 is this one, the x is 0 because it just lies on the origin, and then 8 is just because of the h, the height, the altitude of the triangle. And secondly, we can take this one, we can name this point as -6, 0. And we can name this one as 15, 0. -6 represents this point, it lies on the left-hand side of the y-axis, while 15, positive 15, means this point, it lies on the right-hand side of the y-axis. So we have these 3 important points, and we have actually, in this case, 2 unknown points. So let's say we have here, in this case, x, y, and then in this case we have x naught, y naught. So we can actually express this and this in terms of x or x naught. How? We can express this y in terms of x, and then we can express this y naught in terms of x naught with the help of the equation of the straight line. Actually, we have here these 2 straight lines, so I'm gonna highlight them. This is the first straight line, and this is the second straight line. So these 3 essential points, they are just either the x-intercept or the y-intercept. So that means we can actually use these points to get the equation of the straight line. For example, this one, by using this point and this point, it gives you y naught, equals to -8 over 15 x naught plus 8. On the other hand, we have here, with the help of 0, 8 and -6, 0, y equals to 4 over 3x plus 8. Both must have the y-intercept plus 8. Okay, remember. And so we can express y in terms of x and also y naught in terms of x naught. And what is the purpose to do so? Because we need to find at the end the area of the rectangle by parts, which means in this case we have here the first part of the rectangle, which is this one, which I use the yellow highlighter to shade, and on the right side we have here the red shaded part of the rectangle. So with the help of x, y, and x naught, y naught, we can express the area of the yellow rectangle in terms of x, And this one, for the red rectangle, we can express its area in terms of x naught. We have here x, well, a function of area in terms of x. So xx equals to this x times the y. So x times y equals to x times 4 over 3x plus 8, and then x naught, which is the area function of the red rectangle, x naught times y naught equals to x naught times, in this case, negative 8 over 15x naught plus 8. It must be always 8. So we can make differentiation, and or we can actually try to do the completing square method. So since you are a Form 4 student, you might be a Form 4 student, we try to use completing square method. For example, we try to take this one, we take out the factors, but first we get the x squared, and then take out the factors, which gives you this one, x squared, and then plus, well, for example, in this case, 3 over something. Well, excuse me. Which is 6. My apologies. So this is 6x. And then on the other side, we can have the same, with the same factorization method, we can have this x naught function by factorizing out this negative 8 over 15. We have here x squared. And then in this case, we have negative 15x. All right, so we can complete the square of the expression of each expression. For example, this one, it gives you this. And then on the other hand, we have here well, this coefficients, this constants. And so we can factorize the first 3 terms, obtaining x plus 3 squared minus 9 in this case. And then on the other hand, we have here so in this case, we can actually use this x, and this one, in this case, it should be x naught. This expression, for example, x plus 3 equals to 0, and we will get the x coordinate, which gives you the minimum value, or the maximum. In this case, is the minimum because the x squared has positive value. In this case, the x naught gives you the maximum value because it has a negative coefficient for x squared. And so, but no worries, the negative number for this case, x plus 3 equals to 0, is very normal because it shows that the x coordinate, negative 3, it lies on the left hand side of the y coordinate. And this one, x naught equals to positive, which means that x naught, it lies on the right hand side of y-axis as shown in the diagram. So we have here x equals to negative 3, which is responsible for this part of the rectangle, and then x equals to 15 over 2, which is actually responsible for this part of the rectangle. And so we have here, we are supposed to have 3 actually, but I have no idea why can we have this such a funny thing. Yeah, but everything is good. So we have here, excuse me, yeah, so we have here, this one is -3, so we can just substitute the -3 to get y, and you must get 4. So for this case, on the right hand side, you must also get y not equals to 4 because the rectangle has the same height. So on the same horizontal line, it must give you the same y coordinate value, which is this y equals to 4, and also y naught is therefore equals to 4. So we have -8 over 15 times 15 over 2, and then plus 8. And this gives you, in this case, -4 plus 8, and you will also get y naught equals to 4. So both of these x and x naught values make really good sense because of this reason. Y and y naught, they both equal to 4. And we can actually compute the maximum area of rectangle by adding up x modulus x with x naught, and then multiply with either y or y naught. So in conclusion, the maximum area of rectangle, also x max, equals to the modulus x plus x naught multiplied with y, also equals to this entire expression multiplied with y naught. And so we can have 3 plus 15 over 2 multiplied by 4, and you will have 42 as the final answer. Yep, so the maximum area of the rectangle must be equal to 42. So recap, we can do this, we can solve this problem with the help of the coordinate geometry. But first, we need to find the height, the altitude of the triangle with the help of the Pythagoras theorem, and we will get the height, which is h equals to 8. And then we name 3 important the coordinate of vertices of triangle with concrete numbers, and we try to display the function of each part of the rectangle, the yellow and the red one, in terms of x or in terms of x naught, and we find the x coordinate of extrema. In this case, x equals to -3 and x naught equals to 15 over 2, and we try to compute the value of y and then the value of y naught, and in the end, at the end, we will use the value of x naught, and y or y naught to compute the area of rectangle, which is the area of the yellow rectangle plus the area of red rectangle. And that's all. So any questions, please comment down below, and please subscribe to my channel, and goodbye.